beam of light just hit your eyes. It left the sun 8 minutes and 20 seconds ago. So if the sun vanished this exact second, you wouldn't know, not for another 8 minutes and 20 seconds. You'd sit there, warm, squinting at a light source that no longer exists, watching a rerun broadcast from a star that already went dark. The unsettling truth, everything you see in the sky is old news by the time it reaches you. You're always looking slightly into the past, you just never notice, because the past keeps arriving on schedule. Imagine you're on a video call with someone, except the delay is baked into reality itself. That's basically what sunlight is, a video call from 8 minutes ago that you can never make live, no matter how good your connection is. The sun is so large you could fit 1.3 million Earths inside it. Even light, the fastest thing that exists, needs over 8 minutes to cross the distance between it and us. That gap is the only warning system we'd ever get, and it isn't really a warning at all, more like a grace period nobody asked for. Here's a fact that makes this delay feel real. Sun-tracking solar panels and space telescopes constantly steer themselves using onboard sensors that lock onto sunlight to judge which way to point. Cut the light, and this hardware, built entirely around chasing the sun, would suddenly have nothing left to follow, swiveling uselessly toward a patch of sky where a star used to be. Somewhere, a satellite motor would keep whirring, hunting for a signal that stopped 8 minutes earlier. Say it happens, erased in a heartbeat, without so much as a flicker to mark the moment. What follows isn't sudden chaos. It's a strange kind of silence before a storm nobody can see coming. For the next 500 seconds, nothing changes. Sky's still blue, a kid still mid-jump on a trampoline, hair still catching the light, someone still stirring sugar into coffee, steam curling upward, sunlight glinting off the spoon. Planes keep flying on autopilot, solar panels keep generating power, birds keep drifting on thermals, all powered by light that left a star which no longer exists. Here's the part that gets genuinely strange. The entire planet keeps functioning normally for over 8 minutes after its power source has already ceased to be. Think of a solar farm somewhere in the desert, meters still climbing steadily, technicians sipping lukewarm coffee and watching perfectly ordinary numbers on a screen, while, unknown to anyone, the thing generating that power switched off 8 minutes ago and isn't coming back today. Then the countdown hits 0, and it happens on 3 fronts at once, each one a little stranger than the last. There's no gradual fade like the movies show, no lingering orange, no slow dimming you could mistake for dusk. At noon, the sky turns black in under a second, and stars appear in broad daylight, cold and sharp, as if someone flipped a hidden switch on the whole sky. Turns out they were always there. Sunlight was just too bright to let you see them, drowning out their glow the way a street lamp drowns out a candle. Here's a scene worth sitting with. Standing in a packed stadium at midday, mid-conversation, drink halfway to your mouth, and the entire sky just switches. No warning colors, no warm gradient in between. Just day, then night, with nothing in the middle and 40,000 people gasping in the same half-second. The moon vanishes too, in the same breath. Since it has no light of its own, it only reflects the sun's. Cut the source, and everything borrowing its light goes dark right along with it. The moon, satellites glinting overhead, even the faint shimmer of high clouds catching a sunset that will never happen. And it isn't just what we see. Migratory birds, many of which navigate using the sun's position alongside Earth's magnetic field, would suddenly lose one of their 2 compasses mid-flight, flocks veering off course, calling out in confusion over open water. The sky going dark is only the beginning. What happens next unfolds not overhead, but under your feet. Everything you're standing on, roads, sand, soil, the hood of a parked car, has spent all day soaking up solar energy like a sponge. The moment the sun disappears, that stored heat starts escaping into space with nothing left to refill it, radiating outward the way warmth leaves an uncovered mug of tea on a cold table. Think of it like a phone left in the sun all day, then dropped straight into a freezer, except the freezer is the vacuum of space, and there's no wall socket to plug back into and recharge. Deserts cool fastest within the first hour because dry air can't hold heat. You'd feel the drop against your skin, almost like stepping out of a warm shower into a cold hallway. Coastal cities barely notice, since oceans store heat far too well to lose it quickly. A fisherman out on the water might not even reach for a jacket. Worth noting, how fast a place cools down depends on how much moisture is around it, not how close it is to the equator. Reykjavik, oddly, might handle the first few hours better than parts of the Sahara. Insects feel it before people do. Crickets, whose chirping speeds up and slows down with temperature, would start singing a slower, colder song within the hour, while moths swarm the nearest artificial light as if it's the last sun left in the universe. That cooling curve looks different depending on when in the year it happens, which raises an obvious question. Slightly yes, though maybe not in the direction you'd expect. In winter, the hemisphere tilted away from the sun is already running on borrowed heat and shorter days, so the drop feels less dramatic. It's already cold, breath already fogging in the morning air. So 24 hours of extra darkness blends into conditions people are somewhat prepared for. floor. In summer, the contrast is brutal. Places used to long, hot days and cicadas droning into the evening suddenly get plunged into full darkness and rapid cooling. And the psychological shock is far sharper because it's so unexpected, like stepping from a sauna into a walk-in fridge with no transition at all. Either way, the actual temperature swing over just 24 hours stays roughly similar worldwide, since the season affects starting conditions far more than it affects how fast heat escapes in one day. Ground that started warmer simply has further to fall before it catches up to ground that started cold. Heat isn't the only thing quietly draining away. Something far larger and far less visible is slipping too. Gravity travels at the same speed as light, so the moment the sun's light disappears, so does its gravitational pull on that same 8-minute delay, arriving and departing together like two signals riding the same wire. That pull is the only reason Earth curves in a loop instead of flying off in a straight line forever. This is just Newton's law of motion at work. Things keep moving straight unless something bends their path. For one day, that bending force is gone, so Earth's path stops curving and starts drifting straight instead, quietly, with nothing to mark the shift except the math. Here's a scene that captures it: swinging a ball on a string in a circle, then letting go mid-swing. It doesn't spiral outward slowly, it shoots off in a straight line, immediately, in whatever direction it was moving the instant you let go. That's Earth for one day, with the string cut, still carrying the momentum of a curve it can no longer follow. One day of drift is far too small to send Earth off into deep space. At 67,000 mph, 24 hours barely registers on a cosmic scale, a rounding error against an orbit that takes a full year to trace. But the direction has already shifted slightly, so if the sun switched back on exactly a day later, Earth wouldn't slot back into its old orbit unchanged. It gets recaptured at a marginally different angle, small enough to never feel, but real enough to eventually measure in nudged day lengths, in shifted seasons, in the same slow way that Milankovitch cycles. The tiny, gradual wobbles in Earth's orbit and axial tilt that already reshape our ice ages over tens of thousands of years show how minuscule orbital nudges can compound into something measurable, given enough time. With the sky dark, the ground cooling, and the orbit subtly bent, the next 24 hours unfold in stages, each one quieter and stranger than the last. Hours 1-4. Deserts and mountains cool fast. Oceans barely budge. It just feels like an unusually cold, unusually starry night, the kind where your breath fogs and the Milky Way looks close enough to touch. Chickens go quiet and confused, since their behavior runs on daylight cues, huddling together in coops built for sunset, not for a night that never announced itself. While nocturnal animals get an unexpected, endless golden hour, owls hunting long past when they'd normally settle in to roost. Crickets and frogs, which take their evening chorus cues from fading light, start calling early and then fall into confused silence when the night doesn't end on schedule, leaving an eerie gap where sound should be. Animals give away the disruption long before humans do. Long-haul truckers might be among the first people to notice something's wrong, headlights cutting through darkness that arrived hours ahead of schedule. Hours 4:12. Photosynthesis has already stopped completely, though plants won't visibly wilt yet. They're coasting on stored sugar, not unlike someone running on adrenaline for a few hours before the exhaustion catches up and the legs finally give out. The real damage is underwater. Phytoplankton, responsible for roughly half of Earth's oxygen, needs sunlight every few hours with no reserves to fall back on, and start dying now, silently, in numbers too vast to picture, drifting through water that looks exactly the same from the surface. The most serious damage happens invisibly at the bottom of the food chain, long before anyone on land notices so much as a headline. Hours 12:24. Solar power doesn't dim. It dies completely. No cloudy day workaround, straining any grid that depends on it. Imagine a city's control room watching solar contribution flatline to exactly zero at the same instant. Everywhere, all at once. No gradual decline to plan around, no warning chart trending downward, just a flat line where a curve used to be. Meanwhile, your circadian rhythm, which resets each morning from sunlight hitting your eyes, has nothing to reset it. Melatonin keeps climbing with no signal to stop, leaving most people in a disoriented half-asleep fog, the kind where you can't tell if it's been 2 hours or 10. Even Earth's ionosphere, the charged layer normally kept ionized by solar ultraviolet radiation, starts to settle and thin without fresh sunlight feeding it, subtly changing how radio waves travel and, with them, the precision of GPS signal timing, even though the satellites themselves and their atomic clocks keep working exactly as before. What nobody expects, the darkness itself, is survivable. It's the sleep deprivation and grid strain that cause the real chaos. By hour 24, land temperatures could fall 20-30 degrees F in many regions, cold and genuinely risky in places, but nowhere near a flash-frozen apocalypse. It's tempting to picture something far more dramatic than than this, which is exactly where Hollywood tends to get it wrong. Films show oceans freezing solid by breakfast, ice creeping up windows in fast motion. Real physics moves slower. Earth's oceans and atmosphere store enormous amounts of heat, and one day barely dents that reserve, like trying to cool a filled bathtub by cracking a window for an hour. Surface ice wouldn't even begin forming for weeks, not hours. The actual danger was never the temperature. It's a species that's never once, in 300,000 years, experienced total darkness at high noon, and the unease that comes with a wrongness the body recognizes before the mind can explain it. It's panic spreading faster than the cold, rumors outrunning facts on every phone screen still lit by a fading battery. It's grids failing city by city as heating demand spikes right when solar power hits zero. Picture the scramble in a single apartment building, heaters maxed out, elevators overloaded, everyone's phone flashlight on at once, hallways smelling faintly of overheated wiring, a tiny preview of a planet-sized version of the same problem. And then, as suddenly as it left, it's back. Light and warmth snap back in an instant, but Earth's orbit doesn't reset to exactly where it left off. It gets recaptured on a slightly different path, the way a record needle settles back down a groove over, not the exact groove it lifted from. Orbital mechanics suggests the shift is genuinely tiny, plausibly on the order of the kind of fractional timing nudge that leap seconds are designed to correct for, while over much longer timescales. The same category of small orbital changes drives Milankovitch cycles, the gradual wobbles in Earth's tilt and path that steer ice ages across tens of thousands of years. A single day's disruption is a whisper by comparison, but it belongs to the same family of effects. Either way, the planet that gets its sun back isn't quite the one that lost it, which is really the whole story, condensed into one line. We treat the sun like it owes us nothing, but it's the reason gravity holds this planet on course, the reason your body resets every day on its own, the reason oxygen keeps flowing from oceans you'll never see, the reason a cricket knows when to sing and a bird knows which way is home. Take it away for 24 hours, and you find out how much of this planet was quietly running on a promise that's never once been broken in 4.5 billion years, a promise so constant that we built our clocks, our crops, our migration routes, and our own bodies around never having to question it. Right now, 93 million miles away, it's still burning, completely unaware that we just spent a few minutes imagining the moment it doesn't.